Good afternoon, ladies and gentlemen, colleagues, attendees. We are beginning the panel session of the defense of the thesis by Pavel Golubkin. The thesis is submitted in conformity with the requirements for the academic degree of the candidate of science in physics and mathematics. The specialization is 250025 Oceanology. The topic, wind wave generation in extreme conditions, based on satellite altimeter data and modeling. By rector's order as of the 20th of March 2018, number 21/1, I, Professor Evgeny Zakharchuk, Doctor of Science in Geography, Professor and Acting Head of the Department of Oceanology, SPBU, was appointed Chair of the Dissertation Board. Allow me to introduce my colleagues, members of the Dissertation Board. Tatiana Begonenko, Doctor of Science in Geography, Professor of the Department of Oceanology, St. Petersburg State University. Leonid Lopatuhin, Doctor of Science in Geography, Professor of the Department of Oceanology, St. Petersburg State University. Alexei Zimin, Doctor of Science in Geography, Chief Research Scientist at the Laboratory of Geophysical Boundary Layers, Shirshov Institute of Oceanology of the Russian Academy of Sciences. Sergei Zelentkevich was supposed to join us remotely, Director of Research, Institute of Atmospheric and Earth Systems Research, Helsinki University, Finland. However, due to technical constraints, he cannot attend the session. Under the federal law of the 23rd of May 2016, of the Federal Law of Science and State Scientific and Technical Policy, St. Petersburg State University is entitled to confer academic degrees. The corresponding order on the procedure of granting academic degrees at St. Petersburg State University was issued on the 1st of September 2016, number 6821/1. According to item 17 of section 3 of this regulation, the panel discussion is valid, providing 2/3 of the appointed board members are present. The total number is not to be fewer than 4 people. Our dissertation board comprises 5 people, 4 of which are present. Therefore, we have a quorum. The panel discussion cannot exceed 2 hours. Now let me announce the agenda. Number 1, the chairman's presentation about the documents submitted by the candidate for the degree and the conformity with the requirements. Chairman's reply to questions, if any, 5 minutes. Number 2, the candidate's presentation providing an overview and findings of the research, 20 minutes. Number 3, questions to the candidate regarding the presentation, no more than 2 minutes for each question. Number 4, chair's overview of the submitted reports on the thesis, 5 minutes. Number 5. Number 6, reports on the thesis, reports by the board members. Candidates' replies to the reports on the thesis. No more than 5 minutes per each report and each answer of the candidate. Number 7, questions from the audience. The floor will be given to non-board members and to non-board attendees. They can give a brief account of their ideas and or ask questions to the candidate about the research. No more than 5 minutes per person. Number 8, the candidate's comments about the talks given by non-members of the board, no more than 5 minutes. 9, presentation of the candidate's thesis supervisor. Number 10, open balloting, the discussion of the results of the defense on the issue on conferring or non-conferring the academic degree. Both members provide their conclusions about the candidate's presentation and the defense. Then open balloting, vote counting and recording the results in the minutes of the session, 5 minutes. 12. Deciding upon conferring or non-conferring the academic degree. The final item, candidate's closing speech, no more than 2 minutes. Before we proceed with the agenda, I kindly ask you to switch off your mobile phones. Let me inform you that the panel session of the Dissertation Board is being recorded and broadcast on the SPBU website. The defense. Let me proceed with the first item of the agenda. Thesis by Pavel Golubkin was submitted in conformity with the requirements for the academic degree of the candidate of science in physics and mathematics. The specialization is 250028 Oceanology. The topic, wind wave generation, approved for defense by the order of the SPBU Academic Secretary on the 20th of March 2018, number 2025/1. The candidate has submitted the following documents to the SPBU Academic Secretary. Number 1, an application to Professor Nikolai Kropachev, Rector of SPBU, on the approval of the thesis for defense, submitted on the 20th of December 2017. A copy of the university diploma, a letter of verification certifying that Pavel Golubkin passed the qualifying exams during his postgraduate course, a report of the scientific supervisor by Vladimir Kudryavtsev, acting director of the Laboratory of Satellite Oceanography of the Russian State Hydrometeorological University, a list of publications comprising 10 items published in the journals recommended by the Ministry of Science of the Russian Federation, including 5 papers published in the journals indexed by Web of Science, Web of Science co-collection. Also, thesis in Russian and English, a printed version with its manuscript copyright and a digital copy. The above-mentioned documents comply with the relevant regulation. Members of the Dissertation Board, are there any questions that you have concerning the agenda? If there are no questions, let us proceed. Pavel Andreevich, you're welcome to take the floor. You have 20 minutes.
Good afternoon, ladies and gentlemen. Distinguished members of the Dissertation Board, colleagues. So today's satellite readings are the crucial tool in ocean research, especially in remote areas, where these readings are an only source of information to measure the sea state, including the Arctic region. So in this case, the wave generation is highly crucial. Due to the larger spatial scales of generation, this is a high threat to offshore oil and gas platforms. Satellite readings of the wind wave generated by extreme atmospheric phenomena include the tropic cyclones and polar lows up to 85 meters per second. Polar lows are the most intensive subcategory. So in tropic cyclones, the wind wave can be simply described by way of a very simple parametric model. Nevertheless, the results are not trivial. In some cases, the wave heights can increase and be higher than the wind speed. Such freak waves are a huge threat and have to be analyzed. Therefore, the objective of my research is experimental and is theoretical. I'm going to analyze the wind waves generated by tropic cyclones and polar lows in the Arctic regions. On the slide, you can see the key provisions of my dissertation. So the key modal instrument is the self-similarity theory. This theory allows us to express the wave spectrum by way of a universal function. So this is dimensionless energy in the spectral peak. So over years, there were lots of research that assessed these dependencies. And here you can see some of them. In my dissertation, I use the dependency by Babanin and Solovyov. In my dissertation, I generalized the wave generation theory, which is the results of the preserved wave spectrum. So the solution is the energy spectrum at the peak frequency, considering the wave age. And this is how I generalize the two equations in space and time. This is applicable in wave generation by the wind front, which means that there is a limited wave field. To this end, I use a specific system of coordinates, which allows us to see that waves generated at a specific point initially move backwards because their speed is not higher than the speed of the front. So at the freak point, the waves start to move forward. And this is how I obtained an equation for the maximum height of waves. This is a specific equation to measure the energy of waves. Considering the two cases when the direction is with the wind front and counter the wind front. Here you can see that with higher field velocities, waves start to move backwards and then forward. As a result, the wave height could be by several factors higher than the stationary field. The wind wave generation in tropic cyclones, which are widespread in Atlantic, Pacific oceans. In tropic cyclones, the wind can achieve up to 85 meters per second, with waves being higher than 20 meters. However, higher wind velocity does not necessarily result in higher waves. Therefore, forecasting is challenged. The wind waves is characterized by the fetch, by the trapped fetch effect, especially in cases when the wind direction coincides with the cyclone direction, which results in freak waves. And this is actually how the trapped fetch effect is manifested. I demonstrated the freak waves following other research. Here you can see an infrared image of a tropic cyclone. The black arrow shows the motion, and you can see the track. The measurements are to the right. On the right, you can see that the wave heights are higher than in the left. I also established a measurement database by way of satellite altimeters. I analyzed the tropic cyclone trajectory using data of an American center, a forecasting center. I also used the altimeter satellite missions to measure the centers of the tropic cyclone. Here you can see the cross-section of the right center. So whereas diagonally the real cross-section inside, in the very center of the cyclone, is equal to 4. Here you can see the wind velocity for Isabel's cyclone. To the left, you can see the data of H-Lind analysis, which is considered to be one of the most reliable tool. I included satellite measurements and contact readings as well. To the right, you can see these data presented diagonally. The altimeter measurements for wind velocity shows that the cyclone velocity is underestimated. Therefore, I used a correction method as well as a specific metaphysical function that allowed me to reconstruct higher wind velocity. Here you can see the equations for this cyclone, the graphs, and the infrared image. The black arrow shows the direction and altimeter measurements. You can also see that in the right, the waves are higher than to the left. Again, another infrared image. However, I did not have H-Lind data for this particular case. Nevertheless, I reconstructed the wind wave by way of fast track. Here you can see the fast track data, which is an uninterrupted line, and the altimeter data is in gray. Wave heights. To the right, you see the wave heights are higher. A similar case, you can also see that the wind wave, according to altimeter readings, demonstrates higher speeds to the right than to the left. In that case, you have to analyze what is behind the asymmetry, whether it is the trapped effect or other factors. So what are the modeling approaches? Those are the numerical models. Their advantages are that they represent a normal disruption field. But the shortcoming is that it takes too long to perform such an analysis. Here you can see the Helmholtz's work and the modeling of the fetch, as well as the calculation results. The fetch is assessed based on the wave kinematics in the cyclone. You know, this model for tropic cyclones can be applied in the following cases. The wind speed is limited from both sides. We use the ideal wind field and made the calculation for the diagonal measurement, both for the left and the right sector. Here you can see the calculations for the modal wind field in the right and the left square, as well as the calculation of significant wave heights, the peak energy, and the height and the peak height. The cyclone velocity is higher and the wave height is higher. As soon as the threshold measure is attained, the cyclone does not generate any freak waves due to the fact that the overall wave velocity cannot reach the cyclone velocity. Here you can see the calculations for these particular cases. At the bottom and in the center is the calculation for H-Lind and best track, and then you can see the altimeter wind velocity. The non-interrupted line is according to the model, and the interrupted line is for the stationary cyclone with 0 velocity. You can see that the stationary cyclone is underestimated in terms of energy, so this model overall covers the maximum values. A symmetrical wind field is another case. Once again, here we cannot attain the observed heights. However, the developed model demonstrates them quite well. Once again, the symmetric wind field does not allow us to attain the observed wave height readings, and therefore we see that the wind waves can be caused by the wind field asymmetry. Thus, the parameters are the wind velocity and the radius. Once these parameters satisfy the resonance conditions, then the maximum waves are generated. So within the framework of 1 to 3 of the freak, the energy is going to be higher 5, 6 to 7-fold than the expected measure. Here you can see the wave enhancement criteria and different cyclone parameters. The other objective is to analyze the freak wave generation in the northern pole. Such cyclones are spread in the Japanese Sea and in the Nordic seas. However, the waves generated by the polar low have been overlooked so far. This is the classification of polar lows based on satellite readings from 1995 to 2009. Here you can see their track and the distribution over the year of the wind velocity. The parameters of polar lows, the diameter, the distance, the velocity. This model requires 3 parameters, as I said. Those are the wind velocity, the motion velocity, and the distance. The climatology produces 2 parameters and the overall polar low size. Therefore, we had to obtain the ratio of the maximum wind velocity to the polar low diameter. Here you can see the Greenscott data. These are the ratios. And then to increase the selection, we did the reanalysis. Therefore, we had to simulate the polar lows generation. As a result, the Arctic RCS analysis allows us to simulate more polar lows than the global analysis, with the overall velocity of 15 meters per second, generated in over 50% of cases. So the ratio is as follows. Here you can see that the maximum wind velocity demonstrates at the distance equal to 1/4 of the initially documented. So these are the parameters of polar lows used to calculate wind wave generation. As a result, we generated modal parameters and as well as their statistics and distribution. The modal calculation for the diameter, the velocity, both for maximum wind speed and at the bottom, the lower and the medium wind velocity. Here you can see the resonance lines where waves achieve ultimate heights. If we increase the velocity, waves are going to decrease in height. Here you can see the calculations for all possible diameter sets. However, do the observed polar lows generate freak waves? Yes, they do. On the slide, you may appreciate the distribution of this phenomenon, the resonance line depending on wind velocities, and the substantial part of polar lows is within the indicator spectrum. The distribution of significant waves calculated by way of polar lows, the distribution function, the wave height distribution for stationary cyclone, considering the velocity marked in red, you can see that this function expands with higher waves generated by way of trapped Freak effect, as well as lower waves when the velocity is too high to generate waves. The distribution of waves generated by polar lows with the wave height over the preset value. You can identify the most impacted waves with a height of over 12 meters. Those are the Norway shore coast, the Spitsbergen, the Newland archipelago, and other territories. We also considered the wind fields in the Arctic region. The ice area is shrinking now, and therefore the wave generation is becoming a crucial issue. Altimeter readings were collected in the Russian Arctic over 2002 to 2013 for the Kara, Laptev, and East Siberian seas. We analyzed the ice-free areas and selected them by the thickness of the ice. Overall, 4,117 measurements were selected. To the right, you can see an example of such measures and the dependency of the wave height on the ice-free surface and its in square meters. You can see the median, and there is a trend towards growth with the generation and with larger generation scales. And this empirical dependency is very well described. We could not do away with this well. So here you can see the sea surface and the sea state based on model spectrum. As a result, the mistake was corrected. This mistake is quite regular in measuring dimensionless freaks, and therefore the assessment can be faulty, with the wind velocity being higher twofold than in reality. Then the wind field was calculated. Several examples are presented on the slide. The isolated areas and the satellite readings. The altimeter track, the black arrow is the wind direction, the wind velocity and its values, and the wave height calculation. You can see that the calculations are in conformity with other values. Another case, just a similar case. The resulting measurements for all these four cases present the dependency between dimensionless energy and dimensionless freak. You can see that the empirical correlation is very indicative. And the key results of my analysis, and I'm not going to read them out, the list of papers published. Thank you very much for your attention. Thank you, Pavel. Well, you did it in 20 minutes. Great. Fascinating. Questions to the defendant, please. Yes, Leonid, please. Well, the freak wave. What do you mean by freak wave? Why is it actually freak wave? Well, a freak wave is a wave that demonstrates higher values. Well, let's take a cyclone. So a freak wave is a wave that is over the value of a regular cyclone, but 2- or 3-fold higher than for a regular cyclone. And therefore, this is abnormal. Therefore, my question is justified by the fact that in oceanology, an abnormal, a freak wave, is something different. So we have a specific abnormal criteria. Well, wave killers, this is a different phenomenon. So it's not a freak wave, it's not an abnormal wave, it's just a higher wave, a too high wave. And one more question. On one of your slides, you say that there is a distribution function of something, but in fact it is not a distribution function. It is the probability density function. Yeah, that's right, you're absolutely right. You should be more careful about that. So these probability parameters are different. Should be careful about going with that. I accept your recommendation. More questions to the defendant? Well, I have a set of questions. First, how did you distribute the wind waves in the Arctic region? Well, we considered all the measurements within a limited and enclosed area. So we wanted to mitigate the impact of swell, and therefore we considered the Barents Sea, where swell is quite regular. So the areas were quite small. Therefore, the swell did not exercise any impact. Thank you. That's clear. Another question. The correction accuracy for altimeter readings, does it any impact? Does it exercise any impact depending on the humidity, the air humidity, and the humidity distribution in the air? So there should be some kind of a tolerance to that. In geographical cyclones, you mean? Or in tropical cyclones? Yes, I believe some tolerance has to be accepted, and we considered this tolerance. There is a significant increase was demonstrated. There is not our own method, it is rather a method developed by French researchers. But the cyclone weakening is demonstrated at rainy bands. So the frequency is lower there. Well, I had two references on the slide to these works by French researchers. Okay, as soon as there was a question about freak waves, what do you mean by waves of maximum height? Did you have any formal criteria? Those are just waves of maximum height. Let's consider the following case. Those are the waves that move in the coordinate system. If the wave field is endless, and in that case they would achieve the maximum velocity. As for cyclones, it was important to find the key point where waves are generated, and these waves are going to be the maximum because they would cover the utmost distance first backwards and then forward. Because that's somewhat unclear. You say that waves move forward and then backwards. What do you mean by that? This is considering the system of coordinates jointly with the cyclone. Well, you have the calculation system, right? Where's the point where you start? How do you select the starting point? It's somewhat subjective, right? It is a little bit biased. Well, let's look here. So we see that this is the moving wind field. So waves started to generate in this particular point. The trajectory goes downwards, then it is reflected, and then it moves forwards. So what criteria did you consider for the reproduction of cyclones according to the database? First, this is higher wind velocity, not over 15 meters per second. What was the first criteria? The wind velocity not over what? Not over 15 meters per second. The second criteria is the vortex, which is over 6. And the third criteria is the difference between the wave temperature and the seed state temperature in pascals. And if the three criteria were satisfied, then this criteria was considered to be reproduced. So considering all the three criteria, those would not demonstrate 90%, rather it's something equal to 60%. What do you mean by regular cyclone? The one that does not move. Well, those do not exist. Well, they do exist. There are cyclones that move very slowly. If you look at their lifespan, the velocity is 0.1 meter per second, or even less than that. But your assessment of cyclone movement is in conformity with the regular cyclones, not polar lows, because polar lows demonstrate the utmost speed, do they? Well, comparing to tropical cyclones, their velocity would be equal, standing at 8, well, as opposite to synaptic cyclones, regular cyclones. Those are dozens. Well, I'm not sure about synaptic cyclones. Oh, thank you. Okay. More questions? Tatiana, do you have any questions? Could you please quickly mention the key parameters of wave generation by tropic cyclones that has been analyzed in your paper? 1, 2, 3, 4. Well, these parameters include the trapped fetch effect, the freak waves generation, the wave height and their correspondence to the cyclone parameter, the wind velocity, the movement velocity, and the wind radius. So we have three parameters that allow us to reconstruct maximum wave heights generated by a cyclone. So there are two particular parameters, right? Two features that you analyze, right? The one and the second. Okay. Another question. Well, you mentioned that polar lows can generate abnormally high waves. What empirical data is behind that? Well, abnormally high waves, as my terminology says, as I showed, if you see this is the resonance line with the waves being high at the maximum height. So these waves are 2.5 times higher than waves generated by regular cyclones. So these lines correspond to the resonance curves. And this is the minimum wind velocity, to the right is the maximum wind velocity, and this is the deviation. You see that the cyclone distribution according to diameters and velocities shows that the most part of them is very close to these lines. So the cloud is somewhere here. And, well, roughly half of those will generate low waves, and the other part is going to generate ultimately high waves. Another question. How can you prove that your method in reconstructing the wind velocity in the coastal area according to altimeter readings has largely enhanced the description of such waves? How do you prove that? Well, I started from the fact that I referred to the Kband correction method. Earlier, altimeters used to use Ku bands so as to consider the sea state, which is a parametric algorithm, and which considers the wind velocity and the wave height. As for the Kband, nothing of that kind was done for that, and therefore my research is there. Once again, here you can see the classical RCS model, and initially at the freak, the wind velocity can be higher, twofold. As for the calculation, here you can see the correction, which is the red line with the black line is the standard algorithm. So this is not significant. So the wave velocity calculation and its results are not significant in that case. However, I believe that for the correction we should use the Ku band. As for the K band, nothing of the kind was suggested. So correction can be large scale, but in reality, in real cases, it is not significant. I have one more question. Could you please clarify what do you mean by resonance mechanism of wind wave generation when passing through a cyclone? Well, it is actually the abnormal waves, the freak waves. Well, like I said, so the resonant waves are the waves that will reflect. Others will go backwards and will stay minimum. Once the overall velocity is higher and the waves would achieve the cyclone quicker, then they would ease out very quickly. As for the resonance waves, they will be presented with the wind impact for the ultimate time. But this is the resonance between what and what? What forces? This is the resonance between the cyclone and the waves generated. Well, it's not clear. It's a terminology. Probably we are speaking different language. Once the cyclone velocity is equal to the wind waves velocity, then we have the resonance. The resonance appears when the group waves velocity is equal to the cyclone velocity. So what's the group waves velocity, the overall velocity of waves? It's increasing. So what are the values? Well, any values. The average cyclone velocity is 8, so the group wave velocity will be 8 as well. One more question. So you had the correct characteristics of polar lows and all sorts of parameters. Well, considering regular synaptic cyclones, comparing two synaptic cyclones, are those more, are the polar lows, do those demonstrate higher values? Are they more in number? Well, I think they are more in number if in the Nordic seas those are 45, so synoptic cyclones will be 10. And therefore, we started to study them just because the spatial resolution was not sufficient. Yes, they're very short-lived and very difficult to register. Well, quite often they are registered by satellites, and it's very difficult to identify those because they can be so short-lived, 3 hours, 6 hours. More questions? Do you have any other questions? I have the following question. Do you see the asymmetry of a wind field and any disturbance in regular synaptic cyclones? Well, we can see disturbance in any cyclone because there is the velocity to the right. So this model works also in synoptic cyclones, right? Well, if we consider that the wind velocity to the right of the cyclone can be mitigated, so if we believe in that, this can be used in case of synaptic cyclones. More questions? No questions. Please be seated. Pavel, have some rest.
Следующим пунктом нашего регламента.
So the next point of the procedure is the announcing the reports and the defendant's replies to the reports. Overall, the dissertation board is presented with 6 reports. One of them is an external report of a researcher who is not the member of the dissertation board. All these 6 reports are in favor of the defendant, All of them were timely downloaded to the official St. Petersburg University website, so everyone wishing could read these reports. Therefore, I would like to urge members of the dissertation board to focus on recommendations and on critical aspects primarily. First and foremost, I would like to announce the report submitted by an external researcher who is not a member of the dissertation board. This report is signed by Sergei Badulin, Doctor of Physical and Mathematical Sciences, head of the Nonlinear Wave Processes Laboratory, Shirshov Institute of Oceanology, Russian Academy of Sciences. This is a positive review, and the critical points are as follows. And Chapter 1 notes that the surface waves generation in changing space and time considers the recent results of the contemporary wave disturbance theory, and this in turn suggested the measurements for the non-stationary, non-conventional wind field. This is used in tropical cyclones and polar lows. The author of the report disagrees with the fact that this is a generalization of the self-similarity theory. To him, here we should rather speak about successful adaptation of theoretical results. Next aspect. A very good word to obey is not suitable stylistically for the style of the dissertation. And Mr. Badulin also does not favor the linear impulse flow. So he thinks that this is an inaccurate term. The author also refers to the fact that the dependencies have not been analyzed, and in this paper, rather he refers to a paper that explains such deviations by way of the dependency by Badulin and Solovyov. And this is the experiment of a very high quality, which corresponds to the theoretical objectives. It is yet unclear how the disruption is generated in the process of freak and fetch. It is quite complicated dependency. The author would rather call this model not generalization, but a model which demonstrates some specific aspects of existing models as well. So the work by Andrei Ushkarov and Vladimir Zakharov is absent, that considers a modal function of the pumping. There are some critical points considering the second chapter, and these points are just technical. The equation 2.8, where the defendant refers to Elf-Hailio 2008 paper. This paper should be compared with a relevant paper by Babadulin and Solovyov. The equation 2.8 is related to the fact that the defendant wants to consider the disruption growth and the saturation growth. The equation 2.9 has a misprint. Page 39, line 4. Waves of lower heights up to 0.2 meters require specific explanations. the regular waves of regular heights lower than 0.5 are usually discarded as non-reliable. The title of Chapter 3, Generation of Wind Waves in Tropical Cyclones and Polar Lows, it does not conform to its contents because actually these aspects are not analyzed there. However, the trapped fetch effect is used in other chapters. The equation on page 57 would benefit from a reference to the Young paper 1993 that estimated the geosite altimeter wind speed algorithm at high wind speeds. This paper, it's a very crucial paper, is absent. Well, some editing. The coefficient is absorbed by the parameters. It is a failing formulation. After the Fourier analysis, it is unclear how do you do the Fourier analysis and how do you reconstruct the bidimensional wind field. You should be more clear about that. The assessment of the ratio between tropic cyclone velocity and the wind velocity should benefit if you mentioned that this assessment is done by way of the dependency by Babanin and Solovyov on the basis of the Black Sea. At least in a higher degree, this is a not appropriate wording. There are some technical points of criticism for Chapter 4. On page 83, you should have disclosed a number of abbreviations. You also should have disclosed what is meant by HOPES abbreviation. Page 94, fields with relative vortex could be synthesized. So this sentence could be eliminated because the next sentence is actually about the same. Page 4, picture 4.10, A and B needs a unified color marking. Overall, this work is in conformity with the above-mentioned requirements. I should also mention that the Russian Arctic is larger than the 3 seas mentioned. Overall, the dissertation is in conformity with the requirements. Next, I would like to proceed to reading out the report by other members of the dissertation board. Mr. Zilinkevich is absent, so I would like to focus on his report. His report is positive.
However, there are some critical remarks as well. By and large, the study is based on the satellite readings. However, the dissertation doesn't describe how these tools work. One more critical remark. The model which was developed by the generation of waves by tropical cyclones is tested on the data of 2 satellite altimeters. However, you should check the reliability of these models, comparing that with the results of numerous quantitative calculations, considering wave models, for example, WaveWatch 3 model. Chapter 3 describes a model which is a 1D distribution of an intersect from front right to the rear left of the cyclone. However, the defendant does not focus on the other waves, on other parts of the cyclone. It remains unclear whether it's possible to apply the same model to calculate wave fields in other sectors of the cyclone, or, which is even better, to design a 2D wave field in the cyclone. Now the floor is given to the member of the dissertation board, Tatiana Bionenko, Doctor of Science in Geography, Professor of the Department of Econology, St. Petersburg State University. You're welcome. Dear colleagues, my review is positive. I really enjoy reading Pavel's dissertation. It's a really powerful research. He put a lot of effort into that and really in favor of the candidate for the degree. I have some minor remarks though. The candidate doesn't specify accuracy in the measurement of the sea height level using the Sarrow and Altimeter tool, neither does he specify spatial resolutions of the analyzed data. Section 2.1.1 of the dissertation reads as follows. Only areas fully enclosed by the sea ice and coastlines were considered to eliminate possible swell influence. This isolation allows to discard swell waves coming from other regions, but it doesn't exclude it fully because it could develop from the waves that were here earlier after the wind ceased. We can't discard it fully. Page 3. It doesn't provide the scale of the generation of X waves. Another remark. One of the conclusions reads as follows. It's a probability of estimation for the emergence of freakways in the open ocean and coastal areas of the Nordic seas. However, we don't find in the dissertation maps of the spatial distribution of freakways in the given water basin. Users really need that, and the estimates are highly abstract, in fact. And finally, when defining spatial distribution of waves generated by polar laws, the candidate doesn't consider wind wave dissipation and wave decay under cover distance. A failure to consider these factors might lead to an overestimation of wave height. We can see that on figures 4.14, 4.15, 4.16. Thank you. Pavel, you're welcome with your answers. Let's start with Sergei Badulin's remarks. Thank you very much for your reports. I really accept the first critical remark given by Badulin. I should have used the term generalization, rather adaptation than generalization, and I accept that. It's a more proper wording, perhaps. What concerns his second remark, I accept that and thank Sergei Badulin for his criticism. The next remark is about the certain idealization of Fitch limited parameters. I accept that as well. What concerns number 4, equation 2.8, taken from Ifrodile and others from the 1997 paper, I also accept that. I provided similar working comments, but only for the equation 2.6 for the dimensionless height of significant waves. The next one is about the short height waves, which requires special comment. I accept this remark as well. The first 2 measurements could have been discarded. Another remark. It's the equation on page 57, where I should have referenced Young. I also agree I should have mentioned his paper in reference to Young on this page. The coefficient and the expansion into Fourier series. This remark is in question. I accept that. I should have provided some detail on that. For every quadrant of the cyclone, we have reconstructed the profile of the wind speed. Then we started the cycle of measuring the distance from the center of the cyclone. Those we had 4 parameters of the wind speed. After that, we conducted the one-dimensional expansion. 2-dimensional field emerged after the cycle was over. Another remark is about the dependencies and some data on the Black Sea. I really accept that remark as well. What concerns formatting, I should be more careful with that in my future studies. Do you find this answer satisfying? These were not my critical remarks, actually. I'm sorry. The first remark about the altimeter reading. Unfortunately, I failed to provide information about how altimeters work. I'm sorry for that. The second remark is about the comparison of model results and wave results, like WaveWatch 3, for example. My dissertation would have benefited from that as well. The next remark, it's about chapter 3. This one about the intersect from front right to rear left sector of the cyclone. Is that possible to apply that model to other sectors of the cyclone? I find it possible to create a complete 2D wave field in the cyclone. We need to calculate trajectories of other waves developing in other sectors and to use less idealistic parameters of the wind field. I've made my first steps in this direction. Remarks by Professor Bilanenko. The first one is about sea wave heights. I failed to mention this data, and I'm sorry for that. Accuracy in wave height estimates is 1.5 centimeters. The height of significant waves is 20 centimeters, and dimensional distribution is 5 to 7 kilometers. The method we used allows to minimize the impact of swell waves. However, we cannot exclude this impact completely. By X, we meant the dimensionless fetch in a particular point. The fourth remark concerned the probability, the estimation of probability of emergence of freakways in open ocean areas and coastal areas of the Nordic seas, about the abstract character about these estimates. I agree I should have provided more maps, especially for freak waves. These are those waves that when the height of waves is twice as high than the wind of speed, the speed of wind, for example. The final remark concerned spatial distribution, which didn't consider dissipation and decay of waves, which might have led to certain overestimation. I agree. I'm focusing on these calculations right now as part of my future research. I'm completely satisfied with your answers. Thank you. And then the floor is given to the member of the dissertation board, Leonid Lopatuhin, Doctor of Science in Geography, Professor of the Department of Oceanology, St. Petersburg State University. You're welcome to take the floor. I'm also in favor of the candidate. Still, I have a few critical remarks. I'll turn to them a bit later. I'd like to say that when listening to the presentation by Pavel Golubkin today, I also jotted down a few remarks. I tried to put them into my questions. Still, I insist that the candidate should be more careful with terminology. Anomalously high waves, abnormal waves, is an absolutely different term, it's a different concept. It's a well-known fact that some waves are higher than the others. This was developed back in the 1950s. You shouldn't have talked about this by way of a discovery. It should have been more accurate with the terminology. And one more thing, I have a technical issue. The slides that you have, don't have numbers on them. Another thing you should have done, you should have given printed copies of your presentation to all the members of the Dissertation board. Because for me, that was really difficult to perceive what you were talking about. Well, now back to my report. You say that your study is relevant because there are no buoy measurements in the Arctic. Well, okay, that's not a big problem, but what you say is not exactly true. They have buoy measurements. There is oil production going there, but well, you should have commented upon that in a proper way. I would say the relevance of your study lies in the fact that this area is really interesting from the economic point of view because of production of carbohydrates, hydrocarbons in that area. So you're talking about the classical approach, talking about these dynamic models. Somewhere in your presentation you touched upon that. You should have provided a more precise wording somewhere early in the dissertation. You say that the validity of the present result is confirmed by the validation using satellite data. It's a bit odd to my mind. Satellite measurements have their own disadvantages. Some of the contemporaries say that it's navigation using old navigation tools like astrolabe. You talked a lot about swell. You should have been more concise dwelling upon that. When you speak about polar laws and reference to Rasmussen paper, perhaps you should have reference to the works by the scholars of the Arctic and Antarctic Research Institute. You say that your data is objective. Well, when you use the procedure of automatic classification, it's based on certain criteria. And this is where this process becomes subjective, it becomes partial. So philosophically, there are no objective classifications. Criteria are set by humans. How can that be impartial? All the remarks that I have made, they are rather suggestions, or I urge you to be really more careful with the terminology, because there are well-established viewpoints, and when you start using different terminology, you should comment upon that. Apart from that, I am in favor of your paper, and you deserve the desired degree. Leonid Iosifovich, thank you for your report. I accept all the comments that you make about the improper use of the terminology. As I said, on the right, the waves are higher. I didn't even try to say that I was the first to discover anything. There are 20 measurements taken from different satellite altimeters. I accept your remark concerning the relevance of the study. Well, talking about the lack of the classical approach and about the numerical model, I accept that. This might be considered as a minor disadvantage of the study. The next question concerned relevance of the results I have obtained. What I meant to say is that satellite data can be regarded as relevant because their errors are known, so we can base our comparisons upon that data. Theoretical results were obtained based on the well-known equation of the energy balance and the commonly used dependencies of spatial wave growth and the classical RSC model. Nonlinear correlation was perhaps the right term to use. The next remark about Zakharov and Badulin works. You were right to say that the breakthrough was achieved back in the 1960s of the previous century. The next remark concerned swell waves. Areas with swell waves were minimized because we focused on the isolated areas of seas. So spatial dependency was estimated along the satellite track, and this coincided with the wind direction. The estimates I found in literature equaled 30 centimeters, and for the new altimeter they equaled 20 centimeters. While talking about polar laws, the definitions were different and there were many disputes among scholars for many years. So finally we preferred the terminology and definitions from Rasmussen and Turner works. Do you find these answers satisfying? Absolutely, thank you. Then the floor is given to the member of the Dissertation Board, Alexei Zimin, Doctor of Science in Geography.
So, Doctor of Geographical Sciences and member of the Institute of Oceanology by Chershov, Russian Academy of Sciences. I would like to express my support in what has already been said. It would be very great to have the handouts, because this would have facilitated our discussions and would have made the Q&A session much easier. As for the dissertation itself, I would like to say that I have been following through for quite many years of what Pavel has been doing, and when ultimately I was suggested to familiarize with this dissertation, I was so much happy to do that. The dissertation is very integral, very consistent and solid, and demonstrates the ability of the author to produce a solid piece of research. However, what was so disrupting is the wording of the key objectives, the key findings of this dissertation. Those are quite disappointing. Those are too many, and they just merely draw the borders of the research, but would not be appropriate to formulate the findings. This dissertation has its huge advantages, has its value, and actually you should have formulated the findings differently. The introduction would benefit from splitting the relevance and the scope of the research, and would have made your introduction more clear. Chapter 2. When you consider the altimeter measures in ice-free areas, you note that these data are best described at the ratio of 2.6, with the wind velocity 2.8, with the freak 25 kilometers. However, you do not anyhow justify these values, though they would largely impact the resulting wind velocity. In section 233, you note that these measures are in conformity with empirical ratio 2.6. However, the mathematical statistics is not referred to underpin this statement. In section 3.1.4, you do not assess the quality of approximation according to equation 3.2. Section 3.2.2, once you comparing the modal measurements with satellite readings, this section is too short and it's not clear what do you mean by that. Section 3.1.2 assesses the correlation of maximum velocity values of the wind in polar lows according to the data obtained by way of two reanalysis of the microwave radiometer. This assessment seems to be faulty and not evidence-based, because you do not refer to the coefficients. Considering the scope of issues, your dissertation would have largely benefited from an integral conclusion, which would be in conformity with the initially identified objectives. All these points of criticism, though do not invalidate your dissertation, it's indeed impressive. Thank you. Thank you, Alexei. Pavel, could you please reply to the points of criticism?
I apologize for the fact I failed to produce a handout. I'll keep that in mind. What concerns about the two separate paragraphs I should have devoted to relevance and state-of-the-art of my research, I accept that. Talking about the fetch, we failed to produce that in the text of the dissertation. The fetch was estimated as the distance from the coast to the first point of measurement. The next remark concerned mathematical statistics and my failure to consider that. I accept that as well. The next one is about section 3.1.4. I accept this remark as well. The next one refers to section 3.1.2 about the fact that this section is too concise and that it required some numerical estimates. I agree with you completely. The next one is about section 4.1.2, the correlation of maximum values of the wind, and the fact that I failed to produce the level of significance. Let me focus on that right now. It's lower than 0.05. Talking about the conclusion and the conclusions that are too wide in scope and too numerous, I accept this remark as well. Alexei, are you satisfied with the answer? Yes, thank you. Pavel, you can take your seat. We have one report which remains.
So, the aspects for criticism are as follows. Section 2.1.1 says that to mitigate the impact of swell, the defendant limited himself to the ice-free areas and coastal areas. However, did you mean also what do you mean by ice-free areas? Does this include the drifting ice? Because this cannot mitigate the impact of swell. On illustration 2.3, depending on the wave generation scale. The defendant explains the altimeter values as per the dependency of L4-Holly is of 1995 and Babani and Solovyev of 1998. The long waves non-generated by local wind. Such an explanation on the one hand is weak, because there is no evidence base behind that. For example, the spectral analysis. On the other hand, this counteracts with your words in point 2.1.2, where the limitation to the coastal area or to the ice-free areas would mitigate the impact of swell. In Chapter 2, you do fail to provide the calculations with the contact measures at anchored buoys and platforms. Well, this overlaps with the criticism of other members of the dissertation board, and I disagree that this data is not there, because in the tropic part of the ocean, this data is ample. The fourth chapter, the defendant demonstrates that the maximum number of polar lows in the Nordic seas is registered, and in the Northern Arctic Ocean is registered in March. Illustration 4.1 and 4.2, the Barents Sea. Regrettably, the defendant fails to refer to the reasons behind such a distribution in space and time of polar lows generation. The overall shortcoming of the theoretical part is absence of the analysis of background sea currents on abnormal wave generation. The wave interaction with wave currents, with water currents, results in the wave generation. Research paper is of 1998. Another shortcoming is the failure to analyze the spectral parameters of wind wave generation by atmospheric phenomena, including tropic and cyclones and polar lows. This is it for my part. Please, you can reply to these points. Thank you.
Professor Zaharchuk, I thank you for your critical remarks. Number one concerns the swell, and where it remains unclear which kind of ice I meant. I meant any kind of ice detected by passive satellite microwave radio meters. Areas with the concentration of ice higher than 15% were considered as covered by ice. This was fast ice close to the coastline, and further to the north it was drifting ice. The mask, which we designed for the isolated areas, is common for land and ice. That is, for open water we used value 1, for ice and land the value was 0. Thus we limited the impact of swell coming from outside areas. The second remark is about waves generated by local winds. Unfortunately, even if we take only isolated area, we cannot completely exclude the influence of swell in all cases. This simply excludes swell coming from outside areas, but swell can manifest itself in the isolated area itself. We focused only on small areas. Sometimes, though, these areas would be as big as a sea. In these cases, I suppose we failed to discard the influence of swell. The next one concerned tropical cyclones. Here, to be effective, we have to consider buoy measurements and satellite measurements, and they have to coincide in one point. I accept the next remark. It's about a failure to produce possible reasons for spatial and time distribution of the generation of polar laws. I accept that, but it was outside the scope of my research. It's a very huge topic and a challenge. This is something that might become the area of my future studies. Talking about background sea currents, it would be interesting to study the influence of sea currents on the generation of waves on the cyclone. This is something I might focus in my future research as well. And except the last one, about the lack of research on spatial and timely variability of spectral characteristics of wind disturbance. I accept this one as well. I'm satisfied with your answers. According to our agenda, the next item is giving the floor to the non-board members among the attendees. Do we have anyone who wishes to speak? No, we don't. So then the floor is given to the academic supervisor of the candidate, Nikolai Kudryavtsev, Doctor of Science in Physics and Mathematics. From the Hydrometeorological University of the Russian Federation. Thank you for giving me this opportunity to speak today. My report was duly uploaded on the SPBU website, so I will not dwell upon that in great detail. I'd like to get more personal and speak about Pavel. Pavel has been working on this topic since 2012, so he started his research 5 years ago. That was part of the Mega Grant program. So we have to thank really the leader of the Mega Grant project, Bertrand Chapron, who made this research possible. It's a comprehensive study, and it was a challenging work. We focused a lot on satellite readings, and Pavel did a great job collecting this data. He designed a comprehensive database. It was really difficult to really grasp that moment when an altimeter would cross the hurricane, and we could only collect maybe 10 cases of this event. So this is where we could obtain really accurate results. Pavel has been really developing his critical thinking skills and has been really getting better and better as a scholar. Talking about the criterion of the generation of freak waves by a moving cyclone, yes, everyone is aware of that phenomenon. However, apart from numerical models, which are really too expensive, what people use are really too simple descriptive models. Yes, we chose the term classical model. There is another more elegant equation which considers the speed of wind and the movement, which allows to use stationary data to forecast the wave height. This is the most vivid outcome of the research. and this was substantiated by satellite readings. Pavel was my graduate student. He was member of my team in the lab. He is a qualified young scholar, and I really believe that he can be awarded the degree of the candidate of science. Thank you. Distinguished members of the Dissertation Board, the next item on the agenda is the discussion before the open balloting. Discussion on the issue of conferring or non-conferring the academic degree. So in this respect, I'm asking you whether you want a 5-minute break or we can continue our work. I suppose we should continue as it is. So I would like all the members of the Dissertation Board give their final brief opinion about the defense and the presentation made by the defendant. Let me start by saying again that I really enjoyed reading Pavel's dissertation. It's a really deep scholarly work written at a high level, and they provided a really favorable review. I enjoyed his presentation, and I really liked the way he answered the questions. I could see that he is fully aware of all the material that he used in his dissertation, and it makes me happy really that Russia has brought up a new scholar. I'd like to pay attention to the scholarly journals his works are published in. He is a young scholar, but these journals are really established journals with high impact factor. So I'm going to vote for. Well, during the discussion, we found out that the study is of interest to the scientific community. I enjoy reading that, as well as the other members of the Dissertation Board. The remarks I had are more of, pieces of advice for your future studies. You are at the beginning of your scholarly career. This is something you might take advantage of in future. I'm going to vote for. Thank you. Mr. Zimin, you're welcome. I'd like to say that the dissertation by Pavel Golubkin is something I really liked reading. I'm also in favor of the dissertation. The number of papers you have published is 10, which means you can be conferred even the degree of Doctor of Science, so you could have waited a bit and obtained that degree in some time. So what I say is that the candidate can be conferred the desired degree. Let me say a few words as well. As well as the other members, I'm in favor of this study. We know that there are certain limitations to altimeter readings. They have their downsides. I find that Pavel Golubkin is really a hard-working scholar. And due to these personal qualities, Pavel Golubkin was able to produce a high-quality research, which doesn't raise any doubt. Its relevance doesn't cause any doubt either. It can find huge practical application, since altimeter readings allow to obtain characteristics of wind disturbance in the time mode close to the real, which is important for maritime transportation, construction of hydro technical infrastructure, oil platforms. What I mean to say, and the results of the research can find practical application. What I enjoyed today is the presentation that Pavel Golubkin made. His answers were all supported by the practical data, and I could see that he is fully aware of what he says and writes about. His publications are found in high-impact journals in econology, so I have no doubt that the research is produced at a high level, and Pavel can be awarded the degree of the candidate of science. As we have discussed the results of defense, I suggest we should turn to the open voting on the issue of conferring or non-conferring the academic degree. Let me remind you that the decision of the Dissertation Board on conferring the academic degree is positive, provided it has received 50% of the votes from no fewer than 3 members of the Dissertation Board. This is in conformity with item 23 of the Order on Granting Academic Degrees at St. Petersburg State University. Tatiana Vasilyevna Belanenko, what's your opinion? I'm voting for. Alexei Zimin, what's your opinion? I'm voting for. Leonid Lopatuhin, what's your opinion? I'm voting for. I, Professor Zakharchuk, I'm voting for as well. I would like to thank one and all colleagues and attendees. Let me announce that out of the 5 members of the Dissertation Board, there were 4 members present, and all of them voted for conferring the degree. So, Pavel Golubkin can be awarded the academic degree of the Candidate of Science in Physics and Mathematics, specialization 250028, Oceanology. The next item on our agenda is the closing speech by the candidate. Pavel Golubkin, you're welcome to take the floor. I'd like to thank everyone. I'd like to thank Vladimir Kudyavtsev, my academic supervisor, for his invaluable advice and supervision, for the fact that he has been supporting me on my way to this day. I'd like to thank Pavel Shatron for his consultations. I'd like to thank the members of the Dissertation Board for the relevant remarks. I will definitely consider in my future research. Thank you. So let me announce that the session is over. Thank you, everyone present. Let me take this opportunity to thank all the organizing committee of the defenses and technical specialists for preparing the documents. Thank you, everyone.